The second directory entry points to the inode of itself. Okay, so when you implement a subdirectory feature in the file system, each directory entry you have to reserve 2 directory entries. Reserve 2 directory entries in each directory. Okay, first one is the current directory, and second one is parent directory. So we're going to come into this concept right in the next slide. Let's go to the next slide. Okay, so these are the list of the things you have to implement. So first one, you have to implement hierarchical directory structure. Make the directory entry can point to not only the regular file, but also the directory file. So in Pintos, there's going to be 2 types of file: regular file and directory file. Okay. And okay, so this very important part. Make the directory entry point to not only the regular file, but also directory file. But what's the details of making this to happen? So this is, I'm going to explain later. The second most important thing is add directory entry with dot and dot dot. I guess you are all familiar with the notion of dot. Okay. For example, when you perform the file list dot underbar star.c, it means that list all the files whose extension is C on the current directory. And the second thing is dot dot. I know that you all are aware that dot dot means the parent directory. So if you perform, for example, cd change the directory to dot dot, means change the notion of change the current directory to its parent directory. Okay, so when you implement a subdirectory, you have to reserve the first 2 directory entry for every individual directory for the current directory and the parent directory. Then of course, you have, let's say this is data block for the directory, and it contains a number of entries. Then you have to first reserve the first 2. The name of the first entry is current directory, and this one points to the inode of the current directory. Inode of current directory. And the name of the second entry is dot dot, so it's 2 byte, and it points to the inode of the parent directory. Parent directory. So when you create the new directory, the directory is going to be not entirely empty. It will contain 2 entries. First one is the inode of the current directory, and the second one is inode of the parent directory. Of course, you can switch the position of the 2, but you have to be consistent all through your code. And then current directory, the notion of current directory is global for a process. So struct proc, or thread structure, you have to add a field to represent what the current directory is. Of course, that's going to be the pointer to the inode for the current directory. All right. And then you have to modify the directory related functions. So file system create, opening a file, and deleting a file. And also you have to create a new system calls associated with a directory. Okay, so the most important part. Now there is a concept of path. There is a concept of path. By enabling a subdirectory, you are now having a concept of path. When every file is on the same directory, or every file is on the flat directory, then there doesn't have to be any notion of concept. But now you have, for example, /user /pintos /source /util /sqish.c, for example. Then these are all. So path is a sequence of directories that each of which has a parent-child relationship. So now there is a concept of path. So these are all paths. Okay. So the next thing is there are two types of path. First one is absolute path, and the other one is relative path. The way to distinguish the absolute path from the relative path is the start of the path, the starting character of the path. In absolute path, it specifies the entire path starting from the root directory. So in absolute path, the path string starts with the root /user /src /pintos /blah blah blah. Then the path string starts with the root. So in that case, this is called absolute path. The relative path is the one start with the dot or dot dot. For example, dot dot /src /util something something something. Then the first directory in this path is the parent directory. Wherever I am, or wherever the current directory is, this path starts from the parent directory. So the location is always relative to the current position or current directory. So this type of path specification is relative directory or relative path. Okay. So this is the things you need to do. There are 5 things. So from 1 to 5. The first thing is now there are 2 types of file. There is ordinary file or regular file, and there is directory file. So there are 2 types of inode. Regular inode for regular file, the inode for the directory. Do we really have to distinguish the 2? Yes, of course. Because in regular file, data block, the data on the regular file is sequenced by streams. So you will have the current offset, and in regular file, you will move this current offset with read and write function. For the directory file is special. It is not just a sequence of byte. It is a sequence array of directory entries. So instead of reading and writing a certain specified bytes, you read a directory entry at a time. So the way to access, the way to read and read from, and the way to write to the regular file and directory files are different. So you have to specify that what type of the file it is. So you will going to add a flag to indicate whether the inode is regular file or directory file. Because you have to differentiate only 2, you will need 1 bit. 1 bit is enough. However, there is no way to single bit in our data structure. So you might end up allocating whatever the smallest data structure available, a single character, for example, it's 1 byte. And in a data structure called struct thread, you have to define the notion of current directory. Okay, this is pointer to the inode of the current directory. And then when creating a new file, creating a file or opening or removing a file, you have to modify it so that each create, open, delete can handle a directory as well as a regular file. And then you have to add the system calls for directory manipulation. You have to add system calls for directory manipulation. For example, system calls for change directory, or you will have to implement a system call for creating a directory, or system call for removing a directory, or stuff like that. Okay. And then you will have to add special directory entries called dot and dot dot. Okay, let's start our journey. First one, you will have to modify the inode structure of on disk. So you'll have to add a flag indicating if it is a file. Sorry, it is a file, of course. Directory is also a file. It is a regular file, or if it is directory file. Okay. So we'll add a regular file flag, a directory flag. So when a file is created, you should set this flag properly, depending on whether it is a regular file or it is a directory file. Okay. Now, before we are moving on to the next topic, remember the most essential thing, task is designing or modifying data structure. So that is the most essential part in writing a software. You first have to define or design or modifying data structure. Okay, this is object. And you have to define what kind of fields it has to have. And then next thing, you define or writing the code or method. It's a method, or you use it as a function, or you use a term procedure, or even you use the term operation. Okay, so you first define the object definition very clearly, and then you define the associated operation, or procedure, or function, or method, or whatever. So currently in the first or second step, we define or modify the data structure to accommodate the concept of directory. In the first step, we modify the data structure for on-disk inode, and then we modify the data structure for the thread to accommodate the concept of thread. Okay. In the second part, we are adding the notion of current directory in the concept of struct thread. Of course, the modification is very simple and straightforward. In the first step, we just add a flag on this kind of structure to represent whether a current directory or current file is directory or regular file. In a struct thread, you simply add a single field to denote what the current directory is. But as in the most other software design, modifying a data structure, even though the modification is simple and insignificant, it may have profound implication implication on the overall software design. So when a thread is created for the first time, when a thread is created, created means that every thread has a parent. It's a thread is created by the parent. So when a thread is created, it inherits the current directory from the parent. It inherits the current directory from the parent. So when a thread is created for the first time, the current directory of the child process or child thread is the same as the current directory of the parent threads. Of course, there is one thread that does not have a parent. What is the thread that does not have parent thread? This is something like Genesis in the creation of the word at the beginning. Okay, what is a thread that does not have parent thread? This is called init process. So when for the first time, when a computer is enabled in electricity, okay, the motherboard is initialized and power is engaged in all the hardware, and then the fan starts to running and you hear some mechanical sounds for cooling fans and etc. And then a hard disk is initialized, CPU is initialized, DRAM is initialized, and then the software is loaded from the hard disk drive to the memory, and the operating system starts to run. And then the very first thread, which is called init process, is created. So at that time, the init process does not have a parent thread. It created by itself. For your fun, so then what is the process ID? What is the process ID of the first thread in the Pintos? Look at the code and find it out for fun. Okay, what is the process ID of the first thread in the Pintos when the system is booted? Okay, so find it out for yourself and write it to the piazza. Okay, let's move on to the next topic. So we have modified undisk structure to accommodate a concept of subdirectory, and we have changed the thread structure slightly, and we added a current directory pointer to a thread. Okay, now it's time to modify the algorithm. Okay, so now we have when we create the file, we first have to parse the path, and we have to parse the path, and then we should create the appropriate directory entry at the target directory, and also we have to create inode. So first thing is we have to distinguish it as absolute path and relative path, and find directory target directory where you have to create the file and create a file. Okay, this is detailed steps of creating a file. Well, of course, we already have a module to create a file in Pintos, except that it just creates a file on the root directory. So all you have to do in changing the file creation is to find the right directory where you need to create a file and create a file on the path, except instead of creating a file on the root directory. So this is the one you have to modify. So examine the path and open directory of the path and allocate new inode and initialize the inode with the newly created file and add the directory entry to the target directory. Okay. But it is important that operating system should be bulletproof and should be written against any failure or exception. What if there is no disk space in the course of creating a file? So you successfully allocate the new inode, you create a new inode for a file, but you just found that after creating all these, you find that directory is full. Then you're creating a new file should fail. In that case, you have to deallocate all the inodes and bitmaps you have just modified. So if you succeed, then you close the directory and return success. And if you fail, then you have to deallocate the inode and return success. Success means that return the value of variable success. This is the name of the variable. It doesn't mean that you have succeeded in creating a file. You may have failed in creating a file. Okay. So you have to modify the algorithm of file creation. Of course, then if you modify the algorithm of the file creation, then you're going to modify the algorithm of file deletion as well. Okay. So this is the details of file creating a file. So this is the name of the file. And then in Pintos, you specify the size of the initial size of the file. So in reality, in Pintos, you always have to create a file in the root directory. But after modification, first you have to parse the path and then create the file on that directory. So, of course, as I mentioned before, you have to distinguish depth path and relative path and parse. When creating a file, you have to add the code to set a flag is directory. This is the name of the flag you may have added to denote that whether a current file is directory or not, and set the path to 0 if it is a regular file. And of course, you have to add new directory entry to directory path. And also you have to modify opening a file. So when you open a file, okay, currently you always find the file on the root directory, but now because there is a subdirectory and there is notion of path, you have to parse the path and find the file on that directory and open it. So just opening the file itself is the same as opening a file as before. However, there is an added step, parse the path and find the file on that directory. So when the path is absolute, you find it from the root directory, find from the root directory. And the path is relative, then find it from the current directory. Okay, that's opening a file. And another step is removing the file. It's the same as before. In original Pintos, we always remove the file from the root directory. Now, after modification, you remove the file from the directory specified by the path. And if in-memory of the target file is for directory regular file, if it's a directory, check. If it's a regular file, you can just delete it. But if it is a directory, then you have to check if the directory is empty or not. And here, we remove the directory file only when the directory is empty. And you have to add a number of system calls about manipulating the directory files. This is change directory and creating a directory, reading a directory, check if the current file is directory, and returns inumber of the inode associated. So first one is changing the directory. We get the path and parses the path and change the current working directory of the process to the target directory specified as parameter to a function. And return true if successful, and it return false on failure. The second thing is making a directory. There is right parenthesis missing. So it creates a directory names dir and return true if successful and false on failure. So read the directory, it accepts a file descriptor name and the name. Let me explain the concept of read dir. It requires a little bit of elaboration. In reading a regular file, we use the function read and passes the parameter buffer and size. In reading a file, this file is represented by descriptor ft, and there is current offset. And then when a system call read is called, the operating system or file system specifically reads size amount of data starting from the current offset position. This is read. Read dir is similar but different. So in read dir, of course, the directory is pointed by ft, and in read dir, directory file is partitioned into directory entry, and directory file also has a pointer that points to the current directory entry to read. So if you issue read dir, this function reads a single directory entry and copies the name of the file in this directory entry to the buffer specified by the name and process the current offset to the next directory entry. That's what read dir is for. So that's the reason why we specify the flag to distinguish the regular file and the directory file. So when application issues a read system call, application does not know whether a given file descriptor is associated with the directory or not. So if the application issues a read for the regular file, the file system passes it and calls just regular read. If the application calls a read on the regular file, then it calls read. But if the application issues read on the directory file, then the file system calls read dir. But it should not be returned by the read dir. The current directory dot and the parent directory dot should not be returned by the read dir. And there is a function is dir. This denotes that whether a current file associated with the file descriptor is a regular file or directory file. It returns true if the fd represents the directory. And the function inumber, it returns the inode number associated with the file descriptor. Okay, so the last part. We have to add special entries, directory entries. The special directory entries dot means it represents itself, and dot represents the parent directory. So when a directory is created, the special entries should be added. There is an interesting property for the root directory. Let's say this is data block for the root directory. This is inode for the root directory, and inode has a pointer that points to the data block associated itself, and the associated data blocks will contain the directory entries for directory entries for root. And the current directory, the first entry will represent the inode for the current directory. And then the second will be the parent entry. However, for the root directory, these 2 points to the same place because root directory does not have its parent directory. Okay, so please be alert. And if these 2 entries should be there always. So if a user tried to remove them, then system core should return fails, and it should fail. So in the directory entry, the first entry and the second entry should not be removable. That's the end of the functions you need to implement. Good luck.